All right, section 10.2, number 25. The table shows the results of a survey in which Americans were asked how long food could be on the floor and still be safe to eat. Part A, if you were to construct a circle graph of this information, what would be the arc measures associated with the first two categories? So the first category, 78%. The second category, 10%. So our arc measures would be 78% of the circle, or 0.78 times 360, which would give us 280.8 degrees. And the second category would be 10% of the circle, or 10% times 360. 10% of 360 is equal to 36 degrees. All right, part B, describe the kind of arcs associated with the first category and the last category. So the first category, 78% of the circle, which is 280.8 degrees, is greater than 180. So the first category would be a major arc. The last category, 4% and 4% of 360 gives us 14.4 degrees. Which is less than 180, so that would be a minor arc. Part C, are there any congruent arcs in this graph? Well, we can see that no two categories are the same, therefore there will not be any congruent arcs. So my answer is no, because no categories share the same percentage of the circle. Okay. In the next section, use the Ferris wheel shown to find each measure. Number 27, measure of arc JH. JH, we want this arc from here to there, which is the same as its central angle, which is 60 degrees. Measure of JFH. So starting at J, going through F, and ending up at H. So basically the entire circle except for 60 degrees. So we need to take 360 minus 60, which gives us 300 degrees. All right, and the next one, we want to find GHK. So GH, and then ending up at K. We can see that its endpoints are on this diameter. So that's a semicircle, which is 180 degrees. Number 33, JKG. J, K, G. Well, from K to G, that's a semicircle, plus we need KJ, which is vertical with 40, so it too will be 40. So we want 180 here, plus 40 there. So we get 220 degrees. Number 35, HGF. HGF. So for HGF, that would be the same as taking JHF and subtracting JH from it. So from I don't know why it's doing that. So we want to take JHF, which is a semicircle, but then subtract JH from it, and then that will leave us with HGF. So we want 180 minus 60, or 120 degrees. Use circle P to find the length of each arc. Round to the nearest hundredth. So remember, length is given by central angle over 360 times circumference, where circumference can either be written as 2 pi r or as diameter times pi. So number 37, we want to find QT if the diameter is 9 centimeters. So for number 37, our central angle is 112. So 112 over 360 times our circumference, which is diameter times pi, where our diameter tells us is 9 centimeters, so 9 pi. So I would just take 112, divide that by 360, and multiply by 9 pi. To the nearest hundredth, we would have approximately 8.80 centimeters. All right, number 39. We want to find RS. So RS, which has a central angle of 130. And RT is 15 inches. So if RT is 15 inches, that's our diameter. So we're going to take diameter times pi for the circumference. So 15 pi. And once again, same operations as before, divide 130 by 360 and multiply that by 15 pi. And round the result, and you get 17.02 inches. And number 41. Find RTS, which would be the entire circle except for this part. So 360 minus 130 would give us 230 degrees. So our length is going to be equal to 230 over 360 times the circumference, where PQ is equal to 3. So PQ, we can see that that is the radius, so we want to take 2 times pi times radius for circumference, 2 pi r. So here, 230 divided by 360 times 2 pi times 3, and that rounds to approximately 12.04 meters. The figure shows the stars and Betsy Ross's flag referenced at the beginning of the lesson. 43. If the diameter of the circle were doubled, what would be the effect on the arc length from the center of one star B to the next star C? So it's saying arc length, which is equal to x over 360 times the circumference, so diameter times pi, and it's saying what would happen if we doubled this value. Okay, so I would have x over 360 times 2d, because now the diameter is doubled, times pi. And we know that if we multiply this side of our equation by 2, because that's what we did, we multiplied the diameter by 2, which is the same as just multiplying this entire side by 2, then we have to multiply the other side by 2. So we can see that if we double the diameter, that doubles the arc length. So we need to say what would be the effect on the arc length. It is doubled. (45) Find each measure round each linear measure to the nearest hundredth and each arc measure to the nearest degree. And I will pick up from here and put the rest on one more clip.